All right, 5.2, day 2, verifying trig functions. We're going to make one side look like the other. How are we going to figure out which side to work on? The side that looks like the most complicated. They kind of look the same. This looks a little more complicated because I see a plus sign, so I'm going to focus on this. All right, so in order to start, like at first, I really wanted to factor out stuff because they both have regular numbers. But if I tried to factor out a 3, it would just be a mess. So I'm not going to do that. The next thing I noticed, there's only cosine over here. And guys, I have a little bit of freedom because they're squared. Anytime the trig functions are squared, I might be able to use one of those properties, and that's exactly what I'm going to do. Right here, yeah, what does sine squared equal? You'll be able to throw this out to me. Yes, it's 1 minus cosine squared theta, yes. So let's drop that in. 1 minus cosine squared theta. Let me bring down the rest of this side. It kind of got a little uglier, but it's all cosine, which is what the right side is. Let's distribute and see what happens. So remember, just got to take it one step at a time. 3 times 1, 3 times negative cosine squared. You have like terms. You have a negative 3 cosine squared theta and a positive 4 cosine squared theta. So negative 3 and a positive 4 is 1. So my answer is going to be 3 plus cosine squared theta, and that's it. We just verified it. Yes. Oh, absolutely. So guys, as we were, let's look at problem 2. So problem 2 has a fraction, and problem 2's left side has 2 terms. So obviously I'm going to be focusing on the left side instead of the right side because it's just sine of theta. When we look at this and when there's a fraction, you have 3 opportunities to work with a fraction. Your first thing is to rewrite the denominator like something else. Your second option is to combine these two. Your third option is to multiply by the conjugate. And we talked about the conjugate yesterday. It would be 1 minus sine theta. The best option is to combine these terms together and then reevaluate where you're at. See that whole number 1? Watch how I rewrite that whole number 1. Look at that green ink at the bottom. This whole number of 1 is going to turn into 1 plus sine theta over 1 plus sine theta. That's the 1. Let me bring down the rest of the problem. Okay. And then remember, guys, all day long, you're either breaking them up or you're putting them together. These are broken up. So I'm going to put these 2 fractions together with the common denominator. Let me rewrite the numerator all on top. Y'all, can I cancel anything out? No. How come this doesn't cancel out that? Because of that minus sign. Remember, it can never, ever be added or subtracted to something else. It can be multiplied to other things. But if it's next to a minus or a plus sign, you are stuck. No canceling out yet. But you're starting to have a little flexibility because this cosine is squared. It's probably going to be something like this on the board. Anytime you have a trig function squared, it's probably one of those things. Look, what if I change the way the top looked? I'm going to write sine theta first. I'm going to write minus cosine squared theta. And then see this 1, which is positive, by the way. It's positive 1. I'm going to put it over here. Can you rewrite this? What's cosine squared plus 1? Cosine squared plus 1. Oh, I'm so sorry. My bad. Let's do negative cosine squared plus 1. Negative cosine squared plus 1. Sine squared. I'm so sorry I didn't include the negative. So negative cosine squared, the cosine moved to the other side. So this is going to be sine theta plus sine squared theta. And that's all over 1 plus sine theta. Well, they're all sines. We went from 3 terms in the numerator to 2 terms in the numerator. I can't cancel anything out yet. Is there anything else I can do at the top? Anything I can do at the top? I can't because they're not like terms. If they both had a square, I could, but I can't add those. What else could I do? How many times is the word sine written on the top? Right here. How many times? Twice? Once right here and once right here, yes? Then we can factor out. If it's written more than once, we can factor. I don't know what it's going to do, but I mean, at least it's something. Let's factor it out. See what happens. There's no guarantees, but if you're stuck, you can always factor it out. Let's factor out sine theta. So when I factor out from that term, it's going to be a 1. When I factor out from this term, there's just going to be 1 left. Does anything cancel out now? They sure do. We're safe because it's inside parentheses. It's not next to a plus or a minus. Good job. So all of that cancels out that. So sine theta. We got the left side to match the right side. Let's keep going. So I'm going to do number 3 with you, and then I'm going to ask you to do one on your own. So here we go with number 3. Okay. So as I'm looking at this, it's really hard to determine like which one's more complicated because they're almost exactly the same. It's just a single fraction on both sides. They look similar. One has a plus, one has a minus. So if I had to go into any secondary criteria, it would be for me to leave one of the main 3 alone. And when I say main 3, I'm talking about sine, cosine, and tangent. I'm going to leave this alone. Focus on this. All right, so let's look at this. It's cotangent. Can you rewrite cotangent with the letters T-A-N? You can. All right, then that's our plan of attack. How do you write cotangent with T-A-N? 1 over. 1 over. So let's do it. Let's see what happens. All right. So cotangent is 1 over tangent plus 1. Look, I'm going to color code this. I'm going to make my numerator in blue. I'm going to make my denominator in red because it's going to get a little crazy before it cleans up. So here's my denominator. Numerator, look at your true or false stuff over here in green. Numerator is 1 over tan theta plus tan theta over tan theta pretty much going to do the same thing to the denominator. We're just going to have a minus sign there. So what did I do? I just wrote the whole number different. That whole number 1, I just wrote different. Now we're going to do the Humpty Dumpty thing. They're broken up. We're going to put them together. Here's the numerator. Here's your denominator. Ugh. That's called a complex fraction. When you have a fraction on top of another fraction with a fraction bar in the middle, this is called a complex fraction. And you don't have to know this term, but the reason why I'm bringing this up, just based on which campus you're from, honestly. When you have a complex fraction, if both of the denominators are identical, they're going to cancel out. Some of your teachers may have taught you that. You guys might not even know that. Those are going to cancel out because they're identical. I didn't teach that. I'm going to keep change flip. So we're going to keep change flip from here. Keep the first fraction alone. When I say first, I mean the top fraction. Okay, there's the keep. Then we're going to change the division fraction bar into a multiplication dot. Keep change, flip. We're going to flip this upside down, multiply by the reciprocal. And then look, that multiplication dot allows me to cross cancel on the top and bottom. So we verified it. So over here on the right side of that equal sign, we have 1 plus tangent theta divided by 1 minus tangent theta, which is exactly what the left side is. So we verified it. Now look what I wrote in yellow. If you can remember, and some of your teachers probably taught you this, if you remember these are the same, if you go from this step to this step, that's cool with me. But remember, it only works when these two are exactly the same. Because it's already one of the big three. It's already in sign. So I'm going to focus on this. So here we go. Cosecant is 1 over sine. I'm going to change the way this number 1 looks. So my numerator is going to turn into this. All right, for the denominator, cosecant again is 1 over sine theta. I'm going to change that 1 to a negative sine theta over sine theta. Put it back together. It's going to be 1 minus sine theta over sine theta. There's your complex fraction. Both of these denominators are identical. So I know that this is going to equal 1 plus sine theta over 1 minus sine theta, which is the exact part as the one that's on the left side. So we verified it. Exact fraction on the left side. Identical. Verified. Any questions on this? Let's work backwards. Let's go ahead and look at number 4. So for problem 4, we got some fractions, but we definitely know we're going to be working on the left side of the paper. I really want to combine those fractions, but I'm noticing that secant and cosecant are these reciprocals. So let me see what I can do with these. So let me just focus on this fraction for a moment. So that fraction, secant, is 1 over cosine. Cosecant, the bottom, is 1 over sine. Let me flip this and see what happens. Change, flip. Y'all, what does this turn into? Yeah, it turns into that. Good. What is this? There you go. We're moments away from doing this. So this is sine theta over cosine theta. Okay. Let me go ahead and bring down the other part of this left-hand side over here. These are tangents staring at you in your beautiful little face. So tangent theta plus tangent theta, those are like terms. So 2 tangent theta, we verified it, equals the right side of 2 tangent theta. Any questions on problem 4? Yeah, we're about done. We're going to do number 6. And then you're going to do number 7. Number 6 is harder. I'll do this one with you. It's not harder. It's more fun. All right. So again, y'all, I know for sure I'm going to be working on this side because that's a single term. All right. Over here. I've got some fractions. None of these are reciprocal. Don't look at that side. None of these are reciprocals of each other. So I'm just going to go straight to adding them. So we're going to find the common denominator. So remember, I'm going to multiply this by that denominator. I'm going to multiply this by that denominator. Okay. So I'm going to draw one long fraction bar because I know what the denominator is. Y'all, it's both of these put together. So cosine theta times 1 minus sine theta. All right, let's look at the numerator. So the numerator over here, oh, look, it's 1 minus sine theta times 1 minus sine theta. We did that in our warm-up today. I'm going to multiply this out in a minute. Let's go ahead and look at what's going on over here. Cosine times cosine is plus cosine squared theta. Okay. Let me multiply this out in my head. So this is going to be 1 minus 2 sine theta plus sine theta squared. Remember, you square the first term, you multiply these two together, and you double it. The last term is the last term squared. Let me bring down that plus cosine squared. Let me recopy the numerator. I'm sorry, the denominator. Nothing cancels out from the top and the bottom, but a big flashing 1 in like neon should be going off in your head right now, because that equals 1. That's the top one up there. It's even written in the same order as we're used to seeing it. Let's replace it with a 1. So this is going to be 1 minus 2 sine theta. Remember, that's a whole number 1. It's a positive 1, so write plus 1. I'm going to recopy the denominator. Y'all, I still got like terms I need to combine in the top. 1 plus 1 is 2. All right, so 2 minus 2 sine theta over cosine theta, 1 minus sine theta. I don't know. What can I do? Like, nothing cancels out yet. I might have to start over. I might have to start over, but look at the numerator. Did we write anything twice? Let's factor out the 2. Maybe we can keep going. So when we take a 2 out, it's going to be that. When we take a 2 out, it's going to be that. We got lucky. What cancels out now? Yeah, that 1 minus sine theta definitely cancels out. They're blocked in, they're being multiplied. Let's cross them out. And then, y'all, 2 over cosine theta is 2 secant theta. So we verified it. So, like down here, if you write something twice, try to factor it out. Just see what happens. Squeeze everything you can out of a problem. Sometimes you might have to start over. Sometimes you might be able to factor, which is that.